All right. The next one is the subtraction of sine of a minus b. And that's sine of the first, cosine of the second, but now it's a minus, cosine first, sine of second. Those are the sines. Now I'm going to do the cosines. Cosine A plus B. It's cosine A, cosine B, minus sine A, sine B. And lastly, cosine of A minus B. That is cosine A, cosine B, plus sine A, sine B. Again, all this comes into play from your two famous triangles, your 45, 45, 90. Again, you got your 45, 45, 90. The ratios are 1, 1, square root of 2. And your 30, 60, 90. And again, like I said, be careful where the 30 and 60, because this could be flipped anywhere. It's a 1, 2 square root of 3. The 3 stick together. So this is square root of 3. 2 is the biggest, so 1 is right here. So we use these formulas when we want to rewrite angles, and then we want to get the exact value. So like I said, find the exact value for cosine 15 degrees. As you can see, I have to use these two or any other ones. Like if I do 30, I can do 300 because it's just 10 times it, or any multiples of these angles. So I know 15 would be 45 minus 30. So, and we're dealing with cosine, so I better rewrite cosine 15 degrees as cosine of 45 minus 30. Well, this is cosine of an angle minus another angle, which is this formula right here. So that gives me cosine of the first times the cosine of the second plus sine of the first times sine of the second. So now we ask ourselves, what is the cosine of 45? Cosine is 1 over square root of 2. I mean, we can write it as 1 over square root of 2, but in a minute we're going to rewrite it as square root of 2 over 2 because we can't keep a square in the denominator. Cosine of 30, 30 is right here. Cosine is adjacent over hypotenuse, so that's square root of 3 over 2. Plus sine of 45 is 1 over square root of 2. Sine of 30, I'm standing right here. Sine is opposite over hypotenuse, which is 1/2. So now we have, I'm going to rewrite this as square root of 2 over 2 times square root of 3 over 2 plus, this is also square root of 2 over 2 times 1/2. So we end up with 3, this is square root of 2 times square root of 3 is square root of 6 over 4 plus square root of 2 over 4. Since they now have the same common denominator, I can write this as square root of 6 plus square root of 2 over 4. Now, that is the exact value of cosine 15. And if we just said find cosine 15 using sine and cosine sums and difference, you can probably use your calculator and do an approximation here of 0.9659. Do I have any questions on this first problem? Again, it'll be easier for me if you open up a mic and say yes or no. Uh, unless you have something, then I'm just gonna continue on. But again, it doesn't matter if it's sine or cosine. You have to be creative in how to figure out how can I get this angle using the 30, the 60, and the 45, or multiples of them. All right, let me go to a fresh screen. The second idea that I need from this section is finding an identity. Find an identity for sine of 3 theta. Okay, and I want it in terms of sine and cosine. An identity means another way of rewriting it. So I got to figure out another way to rewrite sine 3 theta that has sines and cosines. Well, the only thing that we know is from this previous right here, I'm talking about sine. I can say, oh, 3 theta could be 2 theta plus theta, or I can do 4 theta minus theta, or it wouldn't matter which one I use. Like I said, you have to be creative. I want to write it as sine. Let me just stay with simple stuff, 2 theta plus theta. Okay, so now we have sine of A plus B. And the rule for that is sine A, cosine B, cosine A, sine B. So here we go. Sine A, cosine B, plus cosine A, sine B. So this is definitely is in terms of sine and cosine, but we have sine of a double angle. We want to try to keep it as a regular sine and or cosine. So I have to go back and think of how can I rewrite sine of 2 theta, a double angle formula. One way to rewrite sine 2 theta, one way to rewrite this part right here is 2 sine theta cosine theta. And this is another cosine theta right here. Plus, I needed another way to rewrite cosine 2 theta. Again, there's so many, there's 3 of them that we showed you for cosine 2 theta. Like I said before, if I look at this right here, I'm dealing with a cosine times a cosine, so that's cosine squared. So I want to try to pick one that maybe has a square in there with cosine in there to see what's, so I can add things together. The only one I can find out for cosine 2 theta is cosine squared theta, cosine squared theta, minus sine squared theta. This part right here is cosine 2 theta times sine theta. All right, let's see what happens. Again, there is no right way to do this because I chose this part right here for sine 2 theta, and I chose this part right here for cosine 2 theta. You might have chosen a different one, but as long as you have terms of sines and cosines, that's fine. Not sine of 2 angle. We just want sines and cosines. So in this thing right here, I'm going to multiply what I can see here. I got 2 sine theta cosine squared theta, because cosine times cosine. And here, sine theta times cosine squared theta is a sine theta, cosine squared theta. And a sine theta times a negative sine theta is a negative sine cubed theta. Well, that worked to my advantage because I have a sine cosine squared and a sine cosine squared. 2 plus 1 gives me 3. So I end up with 3 sine cosine squared, and I have a minus sine cubed theta. So in this section, that's all there is to this section right here, is knowing those formulas, those identities, sum and difference formulas, and knowing some of the double angle or half angle stuff. Now I should have what do you call it, a formula sheet for you. I'm working on that, setting up all the half angle, double angles, and sum and difference angles, which I should have hopefully by Thursday for you. Does anybody have any questions for me for this section and or anything that I have done? All right, Jonathan, what's up? I know Jonathan raised his hand, so Jonathan, do you have a mic so you can talk to me? Hello, Jonathan. Jonathan. Oh, hold on. All right. Again. Oh, okay. Sorry, John. Okay. Sorry, trying to figure out that mic. Oh, okay. Well, you can type your question here. I can see it from the group chat.
Can you go over after the sine 2 theta, cosine theta plus cosine 2 theta and sine theta? Can you go over after that again?
The second line?
Yeah.
This one? Okay. So sine 2 theta, cosine theta, and cosine 2 theta, sine theta. Okay. Like I said, we want it in terms of sines and cosines, not double angles. So I have to rewrite sine 2 theta. We do have an identity for sine 2 theta being 2 sine theta, cosine theta. That is one identity that we know. So I switched this with 2 sine theta, cosine theta, times the cosine. So I got the cosine times cosine, I get 2 sine cosine squared. Similar with cosine 2 theta. Cosine 2 theta, one of its identities is cosine squared minus sine squared. This is just one of its identities. And again, I chose this because I saw on this left-hand side, I'm going to get a squared. So I rewrote cosine 2 theta as cosine squared minus sine squared times the sine theta. Then all I did was distribute sine times cosine squared and sine times sine squared. That's what gave me the first distribution. Sine times sine squared is sine cubed. And then looking at this two parts right here, we have this guy right here and this guy right here. They have the same variables. They have a sine and cosine squared. So I added the 2 plus the 1, that's invisibly right here. 2 plus 1 is 3. And I just kept that the same.
Thank you.
Mm-hmm. Anybody else with any questions on this 9.3? Hey, Patrick. Patrick, what? Close that door. All right. So if nothing else, then let's see if I can get. I would like to start the review with you guys. Is that okay?
Yep. Are we still on target to have the exam for Thursday?
I was hoping that, yes, I was going to give it a take home. So I'm working on that right now. I'm printing it out. I'm typing it out to be more precise, and then I was gonna send it as an email and to be turned in uh, by Thursday at a certain time.
Okay, thank you.
But if anybody, I don't know if you guys want me to go over the review. I will start there right now.
Yes, please.
All right. I sent out a review, and I believe chapter 9, right? Okay, here it is. So let me start with review for chapter 9. All right. So the first one came from 9.1, and it says find all solutions. Do I need to write the questions or can I just go through the problems? Jesus, you said with this software, can I go back and rewatch this? Yes, because I'm recording this right now, and I'll send you the link to it. I'll even post it on YouTube. And yes, please write the questions. Okay, so 9.1. It says find all solutions to the equation between 0 and 2 pi. And number one, there's two problems in this section. Number one says cosine x equaling 0.6. So first I ask myself, where's cosine positive? All students take calculus. Cosine to be positive is in the first and fourth quadrant. So now I know that I got these. And here is between 0 and 2 pi. So I got to figure out, I have to figure out this angle right here. And I need to figure out this angle right here. Okay. So to solve for this, to solve for x, I got to take the inverse cosine. X is the inverse cosine of 0.6. So I figure out that x is equal to 0.927. So that takes care of this angle in the first quadrant, which is 0.927. So now the question becomes, what is this angle right here in the fourth quadrant? Well, to find the angle in that fourth quadrant, I can take, well, if this angle right here and right is 0.927, then this one is 0.927. So to figure out this angle in the green right here, I'm going to take 2 pi minus that. So the x would be 2 pi minus 0.927. And I get the angle in the green to be 5.356. All right. Any questions on number 1? And you can tell this 5.356 is less than 2 pi because 2 pi is 6.28.
Do you always do pi minus that when you need to get the other angle? Do you always do pi?
Not pi minus. I have to make sure which quadrant it is. Pi minus would have been in the second quadrant when you said pi minus. This one was 2 pi minus to get back to here, right?
Okay.
Does that make sense?
Yeah, so if the second angle,
If let's pretend if cosine was positive in the third angle, the third quadrant, I'm gonna do it in the blue right here. I'm pretending. If cosine was positive here, then I would have to take pi plus this guy, correct? So
okay,
the second angle would have been pi plus 0.927.
okay.
Okay?
Mm-hmm.
All right. Question number 2 in that same setting. Find all the solutions from 0 to 2 pi of sine of x minus 1 equaling to 0.25. So before I start, I ask myself, where is the sign positive? So we go to the side. Where's sign positive? We know sine's positive in the first and the second quadrant. So again, here we go. Angle 1 in red, angle 2 in this yellowish right there. All right, so now we have to solve for x. Just like we did over here, to solve for x, we have to take the inverse function. To get this by itself, I got to take the inverse sine. So we have x minus 1 equaling the inverse sine of 0.25. This, okay, I believe that's 0.253. So x minus 1 is 0.253. So x is equal to 1.253. All right. Oh, the x minus, let me say it this way, x minus 1 is the angle. So this angle is 0.253. So technically this thing in the red right here is 0.253. Does that make sense? See, x minus 1 is 0.253. Whatever this angle is 0.253. So in order to figure out this other one right here, I'm going to say the x minus 1, whatever this angle is going to be pi minus my 0.253 to get that. And we end up with x minus 1 equaling to 2.889. So x is equal to 3.889. Again, this angle is 0.253, whatever this angle is. So this thing in the red is 2.53. To get this angle here in the second quadrant, it's pi minus that, because this was the inverse sine of 0.25. Do I have any questions on question number 2? All right. I'm going to go question number 3. Solve the equation For a value of theta in the first quadrant, give your answer in radians and degrees. Okay. Again, this is from, I believe still, we're in 9.1. So, number 3. And again, this is first quadrant, so I don't have to worry about pi minus, pi plus, 2 pi minus, and all that stuff. But I want the answers both in radians and degrees. So we have 9 tangent 5 theta plus 1 equaling to 10. I got to solve for theta. So I got to get this thing by itself. So I got to subtract 1 first. So I have 9 tangent 5 theta equaling to 9. Divide both sides by 9. We have tangent of 5 theta equaling to 1. To get this angle, I got to take the inverse tangent of that. So 5 theta gives me 0.7853. So dividing by 5, I end up with theta being 0.1571. This is in radians. Now we can take that and change it into degrees, multiply it by 180 over pi, and you end up with 9 degrees. Theta in degree mode. Any questions on number 3? All right, so let's go to number 4. Same process. 5 tangent 4 theta plus 4 equals 2 tangent 4 theta plus 5. Again, I treat this like I'm thinking tangent theta as x, like 5x plus 4 equal 2 times x plus 5. So that's what I'm going to do. I'm going to distribute first the 2 times the tangent 4 theta, 2 times the 5. So we end up with 5 tangent 4 theta plus 4. I got 2 tangent 4 theta plus 10. I want to get the tangent thetas to one side. So I'm going to take this 2 tangent 4 theta and subtract it from both sides. So I'm going to minus 2 tangent 4 thetas from both sides. So we have 3 tangent 4 theta plus 4 equaling to 10. Got to get this by itself, so I'm going to subtract the 4. 3 tangent 4 theta equal to 6. Divide by 3. Tangent 4 theta equals to 2. Get the angle by itself. So I'm going to take the inverse trig, so inverse tangent of 2 So we end up with 4 theta equaling to 1.1071. Divide that by 4. And theta then is equal to 0.2768. Theta in your degree mode is 15.859. Any questions on 3 and or 4? All right, then I'm going to move on. Still in 9.1, find the exact values for all the solutions to the equation. Okay. So number 5, sine of theta equals negative square root of 2 over 2. Again, this requires knowledge of, oh, I know this fraction. This must have came from 1 over square root of 2, which means it must have came from a 45, 45, 90. But then we have to ask ourselves, when is sine negative? All right, ask ourselves that question. When is the sign negative? We know it's in the 3rd and 4th quadrant. So we can figure, we automatically know that this should have been pi over 4 and pi over 4. Okay, but we have to figure out what's this angle right here, from here to here, and this angle right here. Now, there's a lot of ways we can do this. If I know this is pi over 4, then I say pi plus or 2 pi minus, you know. But if you didn't know that, you could have said, okay, theta is the inverse sine of negative square root of 2 over 2. And then you figured out, okay, well, this first one would have been 5 pi over 4. And this next one would have been, let's see, what is that? That's 7 pi over 4. Or I could have said this angle right here, this angle right here, this one that I'm doing in the red, is the same as this angle right here, which is a negative pi over 4. Because there's a lot of ways to name that angle. I could do 7 pi or negative pi over 4. But it wants all solutions. So if I stick with the first one, it was going to be 5 pi over 4 plus 2 pi n, because every 2 pi is going to repeat. And for the second one, I can say it's 7 pi over 4 plus 2 pi n, or I could have said negative pi over 4 plus 2 pi n. There's so many different ways. So choose on one method. to me, it was easier to do the negative pi over 4 because they just went backwards. And this would have been pi plus pi over 4. You know, pi plus pi over 4, which gives me the 5 pi over 4. But anyways, this is all the solutions. So it's either these two or those two or multiples of those. Any questions on number 5?
I'm confused on how you got the 5 pi, 7 pi, or negative pi over 4.
We knew that this is a 45 degree, correct?
Yeah.
So sine of an angle is this. That must have been, let me go back to right here. That must have been a 45-degree angle, which is pi over 4. So we knew that this angle had to be pi over 4 because this angle is the same as the angle in that first quadrant. So I knew that was pi over 4. So again, where's sine negative? Third and fourth. Do you see this one right here and from here to here? To find this angle right here, this is pi, right? Pi plus pi over 4 is 5 pi over 4. So this is a must. That's a must. But this one here, I could have done to get this one in the red. I'm going to do it right here. I could have said 2 pi minus pi over 4. Well, this is 8 pi over 4 minus pi over 4, which gives me your 7 pi over 4. So this one in the red from here to here, going in this direction, from here to here, is 7 pi over 4. But I said, well, another way to name this angle would have been just going backwards, pi over 4. It doesn't matter because this angle, negative pi over 4 and 7 pi over 4, is the same angle. So you could either name it this way or you can name it that way.
All right, thank you.
Mm-hmm. And this last problem from this section, same thing. Tangent theta equals negative square root of 3 over 3. Again, this realizes right here that this came from negative 1 over square root of 3. So we should realize that's from a 30, 60, 90. But the tangent, so where's tangent negative? That's what I need to look at. Where is tangent negative? I know tangent is negative in the second, and it's negative in the fourth quadrant. All right. So if I know the tangent, so I'm doing this in my head right here. Okay. So I want the tangent to be in a 1 and square root of 3. We said the 3 sticks together. So that must have been the 30 degrees, hence pi over 6. Okay. But if you didn't know that, to solve this right here, so theta is the inverse tangent of negative square root of 3 over 3. Okay. It would have gave you a negative number. Why? Because it's going to give you this angle right here. Because remember, we said it's either going to give you, when you do the inverse tangent, it's going to be either in between negative pi over 2 and pi over 2. So it's going to give you this angle right here, which is a negative pi over 6. Well, but I also need to figure out what this guy is from here to here. Well, if this guy is pi over 6, which means this guy is pi over 6, to find this angle, it's going to be pi minus that. Pi minus pi over 6. Which gives me 5 pi over 6. So I know this guy is 5 pi over 6. But there's the question here. Tangent, its domain is from negative pi over 2 to pi over 2, and this does not fit that domain. This right here does not fit. So the only one that I can take is this negative pi over 6, because it's the domain and range of that is from negative pi over 2 to pi over 2. Remember, tangent is only this way right here. So to find all the solutions then, it's negative pi over 6. Oops. And because it's just pi, tangent is pi, so it's plus pi n. That's one thing that you have to keep track with tangent. Tangent's very, very sticky. Any questions on 6? All right. I'm going to go to number 7. This is from 9.2 now. In 9.2, it says, give the quadrant of an angle and the value of its sine or cosine or tangent, and try to do that without a calculator. So sine theta is equal to 1/4. Okay. Well, what do I know? I found in the condition. And theta is between 0 and pi over 2. Okay. So hold on. Sine to be positive, first and second quadrant. I'm restricted between 0 and pi over 2. I'm only restricted to the first quadrant. So I'm done with that. So here's the angle theta. Sine of that theta is 1/4. So this is 1 and 4. That means I got to figure out what this distance is. Using Pythagorean theorem, a squared plus b squared equals c squared. So a squared plus 1 squared equals to 4 squared. A squared plus 1 is 16. A squared is 15. A is the square root of 15. So this side here is square root of 15. Okay. Oh, by the way, this is a plus or minus square root of 15. But we know for a fact that since we're only in quadrant 1, this x has to be just the plus part. Only the positive. So when it says I have the sine of that angle, what is the cosine of that angle? Cosine of that angle is square root of 15 over 4. And tangent of that angle is 1 over square root of 15. So I was given this condition. Because of this condition, A had to be positive. Knowing what it is, I have the sine, so I had to figure out what the cosine and tangent is. Any questions on 7? All right. Cosine of theta equals -2/5. And the restriction is between pi and 3 pi over 2. All right, where's cosine negative? All right, here we go. We know cosine negative in the second and third quadrant. And we need between pi and 3 pi over 2. Pi, 3 pi over 2. So I'm only talking about the third quadrant right here. Okay, so if this is theta, its cosine is -2/5. I'm going to redraw this because I don't like this up there. So if that's theta, -2 and 5. That makes sense. X is negative and the hypotenuse is 5. We need to figure this out. Again, we're going to do Pythagorean theorem. -2 squared plus b squared equals to 5 squared. 4 plus b squared is 25. B squared is equal to 21. So b is equal to plus or minus the square root of 21. So let's do it right here. We know this is the y value. We know it's in the third quadrant, so we have to choose the negative square root of 21. So this has to be negative. So I already have the cosine. So the sine of this angle is opposite over hypotenuse, negative square root of 21 over 5. And the tangent, opposite over adjacent, you get square root of 21 over 2. They're both negatives, but that cancels out. As you see, no calculators involved. Any questions on 8? Ooh, 7:30. All right. Let me pick it up. Number 9, simplify the expression. Your answer should involve only sine and cosine. All right, we are going to simplify. 2 cosine t minus cosine t times 1 minus 3 tangent t. This is not that big of a deal. So first I see something in front of parentheses. I'm going to distribute that out. So let's see what we have. 2 cosine t. Negative cosine t times 1 is a negative cosine t. Negative cosine t times a negative 3 tangent t is a positive 3 cosine t tangent t. All right. Let's see what I can do with this. Oh, look, cosine t, cosine t. These two have a cosine in common, so 2 minus 1 gives me just 1 cosine t. Cosine times tangent. I can write tangent as sine t over cosine t. So when I do 3 cosine, sine over cosine, These cosines cancel out, so I'm left with 3 sine t. All right. Any questions on that one? All right. Use trig identities to solve the trigonometric equation. Exactly. And I want it between 0 and 2 pi. Okay. So here, we want to solve this using identities, and we want to figure out exactly what it is. So number 10, sine 2 theta minus cosine theta equals to 0. When we're solving trig identities, try to just work on one side, usually like this side right here. I want to equal it to 0. So the one thing that I notice is that sine 2 theta again. So I need to figure out a different way to rewrite sine 2 theta. One of the ways that we wrote sine 2 theta was to sine theta cosine theta minus cosine theta equals to 0. Now I see that they both have a cosine theta in common, so I'm going to pull cosine theta out of there. And I end up with 2 sine theta minus 1. So I have something times something equals to 0. One of those somethings should equal to 0. So we're either saying cosine theta is 0 or 2 sine theta minus 1 is 0. So when is cosine theta 0? In my head again, right here and here. So I know that theta is at pi over 2 and 3 pi over 2. That's those two places right there. Here, I need to solve. 2 sine theta equals to 1. So sine theta is 1/2. When is sine theta to be a half? Again, in my head, I'm looking at sine theta. A half is like here and here. There's two places right there. Again, that goes with the 30, 60, 90s or whatnot. I want the sine to be 1, 2. This must be square root of 3. So this angle must have been 30 degrees or pi over 6. So I got pi over 6 here. And the other one right here is 5 pi over 6 before I get to pi. So my solutions to this 10 is theta is, I got pi over 2. I got 3 pi over 2. I got pi over 6 and 5 pi over 6. Those are all the solutions. Any questions on number 10? All right, number 11. Tangent to theta plus tangent theta equals to 0. Tangent 2 theta. Well, I'm going to use an identity for that, and one of those is 2 tangent theta over 1 minus tangent squared theta. Okay. So I need to get rid of this fraction. So I'm going to multiply everything by 1 minus tangent squared theta. That times this fraction leaves me with 2 tangent theta. 1 minus tangent squared theta times tangent theta. Well, 1 times tangent theta is tangent theta. Negative tangent squared times tangent is negative tangent cubed. Well, 2 tangent theta and a tangent theta is 3 tangent theta. These are the same tangent theta, so I got 3 tangent theta minus tangent cubed theta equaling to 0. I see they both have a tangent theta in common, so I'm going to pull that out. So if I pull out a tangent theta, I got 3 minus tangent squared theta equaling to 0. Again, I have something times something equals to 0. Either the first is 0 or the second is 0. So where's tangent to be 0? Again, in my head, I'm going to do it right here. Remember, this is from negative pi over 2 to pi over 2. But I want to get all the way from 0 to 2 pi. So 0 is one of them. The next time it's going to happen is at pi, and the third time is going to happen is at 2 pi. Because if I keep continuing, 2 pi is over here. So that's when tangent is equal to 0. This one right here, I'm going to move the 3 to the other side, becomes a negative, but divide by negative, so that becomes a positive. So I have tangent squared theta is equal to 3. Taking the square root, so tangent theta is square root of 3, plus or minus, by the way. So where's the tangent square root of 3, or 1.73? All right, so this is where we're like, okay, we have to know our tangents, we have to know our unit circle, we have to know all of that to that end. So we have the first one, or you can see tangent. This has to be square root of 3, 1, and 2. So we know this is 30 degrees. This must have been what, 60 degrees or pi over 3. So I know it starts at pi over 3. But I got to keep on going until I get to 2 pi, because it's between 0 to 2 pi. So I know tangent is every pi. So the next one is going to be 4 pi over 3. Okay. Now, that's when it's positive. When it's negative, it's going to be at, if it's negative, where tangent is negative, is going to be at 2 pi over 3. Plus pi, which is 5 pi over 3. So here's this guy is where it's positive square root of 3. This part right here where it's negative square root of 3. And again, you can do that using your triangles and which quadrant is tangent is positive or negative. So theta then becomes either 0, pi, 2 pi, and then I got pi over 3, 4 pi over 3, 2 pi over 3, and 5 pi over 3. All right, so that finishes 9.2. Any questions? All right. And the last section is 9.3. I have 3 problems. I know I'm running out of time, but find the exact values. So number 12 says the sine of 345. So I'm going to write that as 300 plus 45. Why? Well, because 30 times 10 is 300 and I know 45, so we can do this. So this is sine 300 cosine 45. Sine 45 cosine 300. Again, in my head, 300 degrees is over here, from here to here. That leaves this is 60 degrees, right? Which is pi over 3, which makes this 30 degrees. So this is negative square root of 3, this is 1, and this is 2. So the sine of 300 is negative square root of 3 over 2. The cosine of 45 is square root of 2 over 2. Sine of 45 is square root of 2 over 2. Cosine of 300 is 1/2. So I end up with negative square root of 6 over 4 plus square root of 2 over 4. And this is the exact value, negative square root of 6 plus square root of 2 over 4. All right. Let me see if I can squeeze number 13 in here. Cosine 285. Got to be a little creative. 285. Okay, if I take 45 out, I get 240. So if 240 is 180 plus 60, so that can be right over here. So I can do that right there. So I can rewrite this as cosine of 240 plus 45. This angle that I drew here is 240, 180 and 60. So that's 30 right there. This is negative 1, negative square root of 3, and this is 2. So here we go. Cosine of 240 is negative 1/2. Oh, I'm sorry. Let me write the... We know it's going to be cosine of the first, cosine of the second, minus sine of the first, sine of the second. Cosine is negative 1/2. Cosine of 45 is square root of 2 over 2. Sine is negative opposite over adjacent, so negative square root of 3 over 2 times the sine, which is a 45, which is this. I get negative square root of 2 over 4 plus this is square root of 6 over 4, because this negative times that negative. So the exact value is negative square root of 2 plus square root of 6 over 4. I only got one more problem if you guys can stick around with me. I know I'm like 2 minutes away. But this last one, it says, use the figure to find a simplified expression. I want it in terms of y. And the figure goes like this. This is 90. This is y. This is phi. This is theta. This is 2. This becomes the square root of 4 minus y squared. Part A, I want cosine of phi minus theta. So if I want to rewrite that, I'm going to get cosine of the first, cosine of the second, plus sine of first, sine of second, cosine of phi. Phi is right here. Its cosine is adjacent over hypotenuse, so it's y over 2. Cosine of alpha is adjacent over hypotenuse, so that becomes square root of 4 minus y squared over 2. Sine of phi, sine is opposite over hypotenuse, so that is the square root of 4 minus y squared over 2. And sine of theta, which is y over 2. I want everything in terms of y. So these are the same. I mean, they're going to have over 4 over 4. You get y squared of this and another y squared of this. I end up with 2y squared of that over 4. And finally, part B. I want sine of theta plus phi. Again, this is just to iterate, you know, the identities and whatnot. So it's the sine of the first, cosine of the second, plus cosine of the first, sine of the second. Sine of alpha, I'm standing right here, opposite over hypotenuse, y over 2. Cosine is y over 2. Cosine is the square root of 4 minus y squared over 2. And sine of phi is that same thing. All right, so I end up with y squared over 4. A square root times itself is that thing. So I end up with 4 minus y squared over 4. Same common denominators. The y squared cancels out. You're left with 4 over 4, which is 1. All right. So this finishes the review for chapter 9. I will send out tomorrow the test, unless you have any questions for me right now. I will send it out, and I want it to be due Thursday at a certain time. Please take pictures. Please Do all your scratch work on a separate piece of paper and then make it nice and neat. Because I'm looking at these quizzes, I'm like, again, here we go. But try to be as neat as you can. So on Thursday, there'll be no lecture, just a turn-in session on that. If you need any help about this review or 9.3, or you're confused about anything, please, you can email me. I will email you right back. If you want to meet in virtual like this, I can meet virtually with you like this. Or if you want to give me a call, I can give you a call. Whatever, which way you prefer is okay with me. So if there's no other questions, I'm going to stop the recording, but we still